What is a molar property in thermodynamics? Have you ever wondered how scientists describe the characteristics of substances in a way that makes sense, regardless of the quantity? Let's talk about molar properties in thermodynamics. A molar property is a specific characteristic of a substance that is expressed per mole of that substance. This means that it helps us understand how a substance behaves without worrying about how much of it we have. To grasp this concept, we need to differentiate between extensive and intensive properties. Extensive properties, like volume or enthalpy, change when the amount of substance changes. On the other hand, intensive properties, such as temperature or pressure, remain as constant regardless of the quantity. Molar properties are derived from extensive properties by dividing them by the number of moles, making them intensive. For example, consider molar volume, which tells us how much space 1 mole of a substance occupies. Molar enthalpy refers to the heat content per mole, while molar entropy relates to the disorder or randomness of a mole of substance. These properties allow scientists to compare different substances or states without the influence of sample size. Molar properties are particularly useful when studying phase changes, like melting or boiling, and chemical reactions. For instance, knowing the molar enthalpy of vaporization helps calculate the energy needed to turn 1 mole of liquid into vapor. This is essential for understanding how substances behave under different conditions. There's also the concept of partial molar properties. These describe how an extensive property of a mixture changes when the amount of one component changes, while keeping temperature and pressure constant. This is helpful in analyzing mixtures, such as solutions, by showing how each component contributes to overall properties like volume or enthalpy. In essence, molar properties simplify the study of thermodynamic systems. By normalizing properties to a per mole basis, they make it easier to analyze and compare substances, regardless of how much you have. This concept is fundamental in thermodynamics and materials science, helping predict and understand how substances behave under various conditions.